All right, I'm going to do a quick video for chapter 7.3, basically giving what would be the first 5 rules of replacement. Rules of replacement are not inferences. Inferences are basically where you're looking at arguments on a truth table. Rules of replacement are basically saying, like, if you have P wedge Q, it means the same thing. It is logically equivalent as the statement Q wedge P via what we call commutativity. And we simply abbreviate that COM. And what we can do is we can actually do a truth table on this. And, you know, true, false, and we'd get true, 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 and we do true, false, and we would get true, true, false, false, and we would get false, true, true, true. We'd find true on that one, true on that one, true on that one, false on this one. They have the exact same truth value. They are logically equivalent. And so what that basically is doing is we're basically comparing statements, and we're finding statements that are both that mean the same thing. And so all these rules, we could do a truth table. I'm not going to do a truth table, but they're saying these mean the same thing. Unlike rules of replacement, or I'm sorry, unlike rules of inference, rules of inference really have to be done on the whole line. You can't just take like part of it and perform it. But rules of replacement, you can take part of a sentence and you can say, well, if I say, you know, A or B, therefore C, you know, so I have, you know, A wedge B horseshoe C, we could just do that. We could actually perform a rule replacement on just part of it and make it B wedge A horseshoe C. Now you can't, you know, it has to be what's in the parentheses. It can't be like, you couldn't have A wedge B wedge C and then come back and say, you know, A wedge B, I'm sorry, that shouldn't be there. Sweet. You couldn't come back and say A wedge C wedge B. You could do that, but you have to have some other steps along the way. You really have to stick with what's inside the parentheses, or what's, you know, you can't jump between operators. You're only talking about the relationship on one specific part. But you can mix that with on the line. So that's one thing that's kind of different about this, is if you need to kind of change a line a little bit, and you know, like the part in parentheses means like A horseshoe B means tilde A wedge B via De Morgan's, you can, I'm sorry, that's not De Morgan's, that's material implication, sorry. And we aren't going to learn that today. But if you needed to do that on just part of a line to get, you know, A, V, B or something, I don't know, then you would, that would probably lead to a contradiction. You could change just that first part and you wouldn't have a problem. You don't have to change the entire line. You can just change the part of the line, because that means the same thing. And so as long as that statement kind of stays in its spot, you can change part of it. So that's just kind of a little bit of a thing that's kind of interesting about it, is rules of replacement are done on a line, and they can actually be done on just part of a line. As long as you're just talking about the part that's constrained within parentheses, or the part constrained within brackets or something else. So what happens is we're going to learn 5 rules. The first one is De Morgan's. And De Morgan's rule, and we usually abbreviate DM, is the idea that tilde P dot Q or tilde P wedge Q means tilde P wedge tilde Q or tilde P dot tilde Q. Now what happens here is whatever the main operator is within the parentheses has to be switched to a wedge. So if it's a dot, it becomes a wedge. And if it's a wedge, it becomes a dot. But then in order to move the tilde in, you then negate it. So a lot of people know, like in math, like if you have negative, you know, you've got a negation on like 3 plus 4, you can make that -3 plus -4, right? Because, you know, or -3 minus 4, or something like that. You can actually kind of just bring that negation in. But in logic, you actually have to change your operator from plus, or I'm sorry, from dot to wedge, or from wedge to dot. You have to change it from an or statement to an and statement, or an and statement over to an or statement. And you might be saying, wait, I don't know if I follow that. I don't know if that makes sense. Well, let me just kind of explain this a little bit. If you have a statement like, it's not the case that Paul or Quentin is here. It's not the case that Paul or Quentin is here. So I'm saying, look, it's not the case that Paul or Quentin is here. I'm saying Paul isn't here and Quentin isn't here, right? And if I say, well, it's not the case that Paul and Quentin are here, I'm saying Paul isn't here or Quentin isn't here, right? If I say, well, it's not the case that Paul and Quentin are here, well, it's possible that Paul isn't here or Quentin isn't here, but it's not the case that Paul and Quentin are here, right? I'm basically saying one of those conjuncts or one of those two items is not true. When that negation is out front, I'm not negating P and Q individually, I'm negating them together. And so what happens is you will find that if you kind of think about it from a perspective of, sorry, I'm trying to change what I'm doing here. I'm trying to see what I can do. Okay, if you take this and you say, hey, I have, not the case of P and Q, you're not saying Paul isn't here and Quentin isn't here. If I say it's not the case that Paul and Quentin are here, if I say it's not the case that I lied and cheated, right? It's not the case that I lied and cheated. I'm not saying that I didn't lie, and I'm not saying that I didn't cheat. I'm just saying it's not the case that I didn't lie and cheat, right? I may have just been a liar. I may have just been a cheat, but I'm not a liar and a cheater, is what this is saying right here. And so when you do that, I'm really saying I'm not a liar or I'm not a cheater. Same thing here. It's like, it's not the case that you're a liar or a cheater, or it's not the case that you're, if I said, hey, it's not the case that you're nice or helpful, right? So maybe I tell somebody, I'm like, maybe somebody at whatever place I'm going, I'm like, don't anybody let you tell you, it's not the case that you're nice or helpful. I'm basically saying, look, you're not nice and you're not helpful, right? I'm saying both. And so when you say, look, it's not the case that you're nice or helpful, I'm negating the entire statement, nice or helpful. And when I do that, I'm really saying you're not nice and you're not helpful. End of story. All right, so that's De Morgan's. One of the things I used to do when I taught this before, but with this new book, or the online software, it doesn't really allow me that same flexibility. I used to like to come up with kind of ordinary language statements where I would do these types of things, and you can kind of see how this works. And so those are kind of examples where if I say you're not nice or helpful, or yeah, you're not smart or capable, I'm saying you're not smart and you're not capable. Or if I'm saying you're not mean or dishonest, then I'm saying you're not mean and you're not dishonest. So I'm not going to always use negatives. People tend to relate to those kind of concepts because we can kind of catch that a little bit better when we get those. That's why I'm using kind of punitive or negative ones. All right, the next one is commutativity. I've already done this one, so I will be very quick about this. Commutativity is basically saying P or Q is the equivalent, or P and Q is the equivalent of Q, wedge P or Q dot P. You can just switch the order, no problem. Abbreviate it COM. All right. I already talked about that one too much. Associativity. Associativity, or sometimes we just put, assoc like that, is basically the idea if you have like a longer one like P wedge, Q wedge R, or P dot Q dot R, where the operator outside the parentheses and inside is the same. Essentially, it's like, it's basically just saying, it's like 3 plus 2 plus 7. You can do it that way, or you can do it this way. It doesn't really make a difference which way you do it, which order you do it. Order of operation doesn't really matter. So P wedge Q wedge R, or P dot Q dot R, you can just move those parentheses around. We do like to make note of that. That way we're not like, wait, where did that come from? We usually do require that. And if you want to get something like P wedge Q wedge R, and you want to get it down to P wedge R wedge Q, we would ask that you do commutativity to get P wedge R wedge Q via commutativity of this one, and then you do associativity of that one. And that's kind of how we would end up doing that. All right. Next one is distribution. Now distribution, the last one, they all had to be the same symbol. So it was, you know, P dot Q dot R. But this one is a case where what if you have P dot Q wedge R, or you have P wedge Q dot R, either way. Well, then in that way, in that case, we like to do it where we go to P dot Q wedge P dot R, or we like to go to P wedge Q dot P wedge R. Whatever is outside here can be paired with each part inside the parentheses, okay? But they have to be paired with the main operator, and the operator within becomes the main operator. So if you do it, because what happens is this is like saying Paul is here or Quentin and Regina are here. So these are compound statements or whatever, like lowercase, but I'm just going to use them as simple statements. So Paul is here or Quentin and Regina is here. So that's basically saying is like Paul is here or Quentin is here and Paul is here or Regina is here. Now, if it's the case that Paul isn't here, then Quentin is here and Regina, because if Paul isn't here, then Quentin and Regina are here. And if Paul isn't here, then Regina is here. But it's also the case we could just put these together via P wedge Q. We can bring these, we can take this main operator, put it as the part in the parentheses, and we can pair the part outside the parentheses with each of the conjuncts or each of the disjuncts, making it P dot Q or P dot R. And this is the case that Paul is here and Quentin or Regina is here. So basically it's saying is Paul and Quentin is here or Paul and Regina is here. You know, Paul and Quentin is here because it's Paul is here and Quentin or Regina. So it's Paul and Quentin or Paul and Regina. I don't know which. It's Paul. It's one of the two, right? In this case, Paul is here or Quentin or Regina is here. So Paul's here or Quentin's here. That's possible. Paul is here or Regina is here. That's possible. You know. But we also know that if Quentin's here, Regina's here, because Paul not being here negates that. So that's basically the way that works. Is when you move it in, the main operator kind of switches. This is dot is your main operator, wedge is your secondary. You've got to take the part outside, pair it with the parts inside, and sorry, that should be R. And since the operator inside the parentheses was wedge, you make that the main operator now of the whole statement. All right, and then last one we did today was double negation. Now, double negation is really easy. Most of you kind of get this pretty quickly as a concept, but it's one of these, like, it just makes sense to kind of state it. If you have a statement like P, it means the same thing as tilde tilde P. That if you negate something twice, it becomes just the other thing. If I say not P, it means the same as not P. And if you did a truth table on this and you said, like true, false for P, and you had negative, tilde tilde P, then, you put true, false, then that becomes false, true, and then it becomes true, false again. And you look and it's like, oh, they match and they match. So that kind of makes sense. When you negate something twice, if you have that, it becomes the opposite. This is somewhat important when you have like a modus tollens. It'll allow you to do something like, if you have tilde P horseshoe Q tilde Q, and then you get by modus tollens, you get tilde tilde P because you're negating the consequent. So you're now negating this and bringing that down, tilde tilde P. You know that means just P via double negation. We just abbreviate that DN capitals, which also is very similar to DM for De Morgan's, but very different. So that's the way that works. Pretty simple. I'm just going to go ahead and stop the video here. If you have any questions, let me know. Otherwise, we basically take those same things and we apply them back to our process. One thing to keep in mind is if you look in your book or online at the back of each of these sections, there's what they call strategies. So this starts with strategies 10, 11, 12, 13, 14, 15. And they'll say things like conjunction can be used to set up a De Morgan's. And so basically what they're saying is, you know, if you have like, if you have things like, you know, tilde A and you have tilde B, then you could always conjunct those to get tilde A dot tilde B to then get tilde A wedge B via De Morgan's. Or, you know, and so you're basically conjuncting lines 1 and 2. And that allows you to get that. And so these are all kind of strategies. Like it says you could use conjunction or constructive dilemma to then do a De Morgan's, where if you can get like, you know, a tilde, you know, A wedge tilde B, you can then get tilde A dot B by De Morgan's. So if you can see the consequent in the in there, those letters, you can use that. And so I would read through those as you prepare to do this, and those are very helpful, and do some problems. If you'd like for me to do some problems, I guess shoot me an email. That'll give me some idea of how much more to provide. But if you, because I can make those videos pretty quickly, just doing 4 or 5 problems, just sort of walk it through you. But I don't know that most people want that, so I don't want to make a video if you don't think you want it. But if you do, or you think that was something that's missing, please do shoot me an email.